Great. So yeah, hope everyone can see my screen. Welcome to Multimodal Weekly. This is a virtual webinar series hosted by the team at 12 Labs. For those of you who are new and not familiar with our company, we early stage startup focused on building multimodal video understanding technologies. This is an initiative that we've been hosting over the past 2.5 years or so on a weekly basis, gathering practitioners, community members, virtually to discuss some of the newest and interesting topic in this domain. Here are some samples of the type of thing that we tend to cover on a weekly basis. Researchers coming in and share their work, like new research right in multimodal AI and foundation models. Web developers who've been building interesting projects on multimodal video come in, talk about what they have built. Sometimes we have like customer and partners talking about like different application of multimodal understanding in different vertical, and finally like guides and tutorials from internal team member sharing best practices on using our platform and API. Um, so yeah, we recently passed the 100 episode mark like late last year. As you can see here, these are some example of the recent session and the topics that we cover, right? Application of video in advertising context. There's talk about like you know research talk on like proactive assistant, right, for task support, multimodal agents, application of social media challenges, etc. For today's session, back to the new year of 2026, we have two exciting presentation. One is more from a research perspective, and the other one is like more from a kind of builder, engineer type of view. So the first speaker, his name is Chen, currently a PhD student who will present his work, by the way, at HKUST in Hong Kong. So he will present his work called TiViBench, which is a hierarchical manner benchmark specifically designed to evaluate the reasoning capabilities of video generative models. Specifically, this benchmark will systematically assess reasoning across 4 dimension, structural reasoning and search, spatial and visual pattern reasoning, symbolic and logical reasoning, as well as action planning and task execution. So yeah, you probably heard a lot about reasoning models from the language, from the LLM world, but there's not been a lot of work that apply that right to multimodal and video understanding. So really excited to hear more about what Haro and his team has been, experimenting with, right? For the second half of the session, we'll have Ilias Haddad, software developer and content creator, joining all the way from Morocco. He will present his work, which is a open source library, an application called EditMy, a web app that index videos with AI, everything locally using different submodel for object detection, face recognition, emotion analysis, enabling semantic search to natural language query and export scenes. I got a chance to see an earlier version of EditMy not too long ago, and it is very interesting and impressive work that it has built. Very cool local application that you can run even offline. So he will share that with you in the second half of the session. So yeah, that's the agenda that we have today. For the attendees, feel free to send your question on the Zoom chat, and I will surface them with the speaker as they see it. And then we'll also a short Q&A, maybe like 5 minutes for any live question answering right after each speaker finish. So yeah, I will stop sharing my screen. And Harold, do you wanna go ahead and get started?
Okay, thank you. Can you see my screen?
Yes, when see it.
Okay. Okay, hello everyone. Thanks for having me at Multimodal Weekly hosted by Travel Labs. I'm Harold Chen from Hong Kong UST. Today I will share about thinking video reasoning for video generation centered on our work TiViBench. The big picture is video generation is starting to feel like it's approaching a reasoning moment, but we don't really have a clean way to measure that. So we built a benchmark to make reasoning plot measurable and verifiable. And then we propose a lightweight test time strategy with TPO to improve reasoning without training. So let me start with why reasoning is a missing piece To motivate this problem, let me use one figure to capture the whole gap. The figure here frames the motivation. On the left, large language models has evolved from basic understanding to reliable reasoning. And in the middle, can video generative model follow a similar path using frames as intermediate steps? Existing benchmarks are great at measuring fidelity or the coherence, but they're mostly missing systematic reasoning evaluation. That that means we can answer a basic research question: are models getting better at reasoning or just better at rendering? So the natural next step is winning a that explicitly targets reasoning and allows objective checking. That's exactly what TiViBench is. So let me define it clearly before diving into details. So comes the first dimension. Dimension one is structured reasoning and search. Think of a task like a graph traversal and maze solving, where the model has to move through a structure without violating constraints, plot sorting, temporal ordering, rule extrapolation, and game moves. These tasks stress something video models often struggle with, constraint adherence over time. It's not enough to end somewhere plausible. The intermediate frames must follow the rules as the state evolves. If structured reasoning is about navigating explicit structure, the next dimension is about reading and manipulating visual structure, patterns, and spatial relation. So the dimension two is spatial and visual pattern reasoning, shape fitting, connecting color, pattern recognition, over and out, counting objects, or visual analogy. What makes this hard is that the model needs stable representations of objects and relations across frames, especially for subtle distinctions and object permanence. If the model forgets an object or drifts visually, reasoning collapses even if the model looks smooth. So far, this still feels like visual intelligence. The next two dimensions push into what people usually call symbolic reasoning and go direct to the execution. So the dimension three is symbolic and logical reasoning, Sudoku, arithmetic, symbolic relations, visual deduction, transitive reasoning, and rule-based games. These tasks are unforgiving. Small visual errors like a digital shape become reasoning errors. And the final dimension is action planning and task execution. To use robot navigation, goal planning, multi-step manipulation, instruction following, and game strategy. Here we care about whether the model can produce a temporally coherent sequence of actions that causally leads to the goal. So once we define tasks, the next question is how do we actually package them from I2V models, especially through prompts? So our bench contains 595 image prompt samples spanning all 20 to 24 tasks with easy, medium, hard tiers. A key choice is prompt style. For video generation, prompts that are too directive, like find the shortest path, often don't translate into faithful step-by-step behavior. So we use narrative prompts. The goal is clear. Intermediate steps are implicit, and the constraints are implied. We draw prompts with Gemini 2.5 Pro and then do three annotator review to ensure clarity and consistency. Now comes the hardest part of any benchmarks, scoring. If we can to evaluate reasoning, our metrics have to reflect correctness, not webs. So here we use two evaluation modes. First is the final state validation. For tasks where the end state is well defined, like Sudoku completion, we can check whether the final frame matches the target state using OCR or feature-based matching. And the second is the process and the goal consistency. For tasks where the path matters, like maze solving, we need to verify the intermediate trajectories respect the rules, not just the destination. That often requires grounding and tracking. So because tasks vary, metrics are task specific. So we adopt OpenCV for OCR and structured detection, Dino or DynoX for semantic matching, grounding and tracking, and VLM-based QA for planning and tool tasks. For metrics, we report Python 1 and Python 5, which is important because sampling can reveal whether a model has a capability but lack reliability. With tasks and metrics is placed, we can finally ask, what do today's models actually do on reasoning? So here we present an overview chart. At a high level, commercial models show stronger reasoning performance overall, while open source models show lower average performance and high variance. But the more interesting story is not just who is best, it's which tasks breaks which models, and whether performance patterns align with our hypothesis. Reasoning is emergent, but still fragile and inconsistent. Let me anchor this with a few key numbers because otherwise it's easy to lose the scale of the gap. So that's the main tables. On Python 1, commercial models like Sora 2 and the Vue 3.5, Vue 3.1 are clearly ahead. The best open source model in our set, 1.2.2, is around 9% overall. So now the key point, when we move to Python 5, open source performance improves substantially. For example, 1.2.2 raised to 16%. Yeah, this gap between Python 1 and Python 5 suggests the model can sometimes produce correct answer, but it's not reliable, landing on them in a single try. So that observation directly motivates testing method later. So next, to understand what to fix, we looked closely at failures, where models systematically break and why. So here's the failure analysis. We found some tasks remain hard across board, particularly those requiring strict rule modeling and fine-grained symbolic fidelity, like maze solving, temporal ordering, or one-out and Sudoku-like tasks. We summarize this as takeaway three. Failures often come from two roots. First is the insufficient rule modeling. The model violates constraints during motion, even when the prompt implies them. And second, weaker fine-grained visual feature extraction, like small objects, digits, and gray degrees. And one symbol drives the logic breaks. So we have a measurement tool now, but also a practical question. Can we improve reasoning without training? So here we propose a testing strategy, namely VideoTPO. VideoTPO is a simple testing loop. Instead of generating one video and hoping it's correct, we generate two candidates from the same prompt. Then a VIM for cell critic. It compares candidates and identifies strengths and weaknesses. This is our textual loss. Next, it converts the critic into actionable prompt edits, the textual gradient. Then we update prompts and iterate. So importantly, this requires no model fine-tuning, no extra training data, and no external reward model. It's essentially testing performance optimization, driven by analysis, not by the gradient. So the question is this actually move the needle in measured reasoning performance? Yes, substantially. And for Hunyuan video, overall Python 1 improves from 4% to 10%, and for 1.2.1, it improves from 8% to 18%. One announce we also found is that prompts are not uh, model specific. A prompt optimized for one generator may not transfer well to another. That's not a bug. It suggests each model have different preferences or failure modes, and the VideoTPO adopts prompts and testing accordingly. So, in the end, let me close by distilling what I think are the two main takeaways for the community. So first, TiViBench provides a structured way to evaluate reasoning in I2V generation, hierarchical tasks, verifiable targets, and processor-aware metrics. Then evidence suggests reasoning is emergent, but it's still for the evidence suggests the reasoning is emergent, but it's still fragile, especially for constraints and symbolic details. And second, VideoTPO. It shows a practical path to improve reasoning today. A naive self-critical loop at test time can unlock significant gain without training. So looking forward, the big technical needs are better constraint representation, higher fidelity symbolic rendering, and more processor-aware optimization, not just a prettier video. So that's the end of my sharing. Thank you for your listening.
All right, awesome. Thanks, Maro, for wrapping up the early part of the papers. Um, it looks like there's multiple division. Can you still share the screen, just FYI, so people would know?
Okay, okay, okay.
Yes. Yeah, what I really like about this work is like there's multiple contribution, right? Which is uh, everything from data collection and evaluation to an actual like framework, VideoTPO, right? As well as
Yes.
a benchmark. So it's very comprehensive, like right experiment that your team has done to um, you know validate right the feasibility of this reasoning approach. Um,
Yeah.
um, I don't know if I forgot, but did you mention anything about like kind of future outlook? Like what could be the next frontier of like reasoning capabilities? Um, like what I guess like what is the next like direction of continuing this evaluation?
Sorry.
Yeah, like what are the next step, yeah, of this work?
Actually, I also want I'm also wondering this question. Yeah, I talked to a lot of people, a lot of experts in video generation, and we think, yeah, that's a truth that current video models have the ability to generate physics plausibility, yeah, to generate physical plausible videos, but so the reasoning capability is the next stop to train. So I think the reinforcement learning should be the best strategy to show how video models can reason.
Gotcha. Um, so reinforcement learning is a way to, you know, provide all the feedback loop, right? That
Yes.
enable the reasoning capabilities. Um, Another question is around the four dimensions. So you mentioned that like across the four dimension, right? Structural reasoning, symbolic, logical, action planning, as well as spatial and visual. Out of those four dimension, which one, like from your experimental, um, you know, test, which dimension seems to have the most impact, right? Um, to improve the reasoning capabilities of video models.
For the four dimensions, I think yeah, there's gonna be some hardest part and the some useful part. I think the most useful part is the action planning and the task execution. Like recently the embodied AI for robotics manipulation. So I think video generation first it can be a good data generator, and I think the hardest part is the mathematical question. So actually, I don't actually believe that one video generator can understand the math. So I think that's that's a tricky problem.
Mhm. Yeah, that makes sense. It's probably hard for like a generic model to like understand math. Like I think that is more like for a language model capabilities. right?
Yeah.
Perfect. Yeah, that's all the question I have from the attendees and the audience. Do you guys have any comments, feedback, Q&A for Harold related to this work? Yeah, if not, if you have any further feedback later on, you can just put it on the chat and he can answer anything, in the second half of the session. Yeah, like if there's no question, then I guess we can move on to the second speaker.
Okay.
Yeah, thanks, Sarah, for preparing the slide and presenting your work.
Okay, thanks.
Yep. All right, Ilias, do you want to get started? You're still muted, by the way. All
Can
right.
you see my screen?
Yes, I can see it.
Awesome. So thank you, James, for this opportunity to share the project. So currently, I will be talking about Ilias Mine, which is a local video indexer, and will be the product. But first of all, let's a quick introduction about myself. I am Ilias Haddad. I'm a software developer and a content creator. I work with multiple startups, including one in the video space, which we call the Edit Frame. So for today's agenda, I will be talking about the story first, why I built Its Mine. The second thing, it will be the process of indexing. And at least at the end, we'll be showcasing Its Mine. So for me, I have a lot of video. I have almost like a 5 or 6 terabytes of video from shooting content from my YouTube channel or like a personal video. But when I'm searching for a video, it will be taking me a lot of time and a lot of thinking. And the image is like something that will be for me in my personal computer, a lot of video, but I couldn't find the exact one because I have to remember where the video has been shot. And sometimes it will be hard for me to watch the full video to get the exact part that I am looking for. So it all started with a simple CLI that will take a video folder and transcribe all the video using OpenAI Whisper model. So later on, I can search my video using the transcription that I got from Whisper. But it was very basic, but it doesn't fulfill my need. So I decided let's add one more thing. And the other thing was frame analysis. So currently we transcribe the video, and the second thing it will be frame analysis. So we take the video and split it into smaller parts that will be 2 or 2.5 seconds in terms of duration. And we take like a 1 or 2 frame per that like a video part and do some frame analysis. For example, get the recognized faces, object, text that appear on the screen, and describe the frame using some local AI model. And we'll be saving the data over a local vector database. I'm using ChromaDB, and I build for the start a simple UI to just search and chat in a desktop application. So this is what the initial plan. But after getting it working and the proof of concept is working, I decided to make it open source. And I publish it over GitHub and I share it over Reddit. And the community love it and give me some great feedback that helped shape the product that I will be presenting right now. And I would like to mention that to give some shout out to this community. So this is the timeline of Edit Mine. It starts with a simple CLI, move on to a desktop application. Right now it's like a Docker container. So it will be running on any server or computer that have Docker installed. And let's go to the technology and what is powering Ilias Mine, because as I mentioned before, everything is local. So the indexing is working like this. So the process is simple. So we take the video, we transcribe the full video using OpenAI Whisper model. So we are using faster Whisper, a Python library for doing that to transcribe the video. After that, we move on to frame analysis. So we split the video into a smaller chunk or parts that will be 2 or 2.5 seconds, and we extract a couple of frames that will be 1 or 2 frames per video scene and run the frame analysis plugin that we have. So the Python script is plugin based. So we have some plugin for face recognition, and I will be talking about the model that I'm using for each plugin later on. And we are using object detection. We are using OCR for the text that will be appearing on the video. And also we have a model to be able to describe what they are seeing in the image itself, because it will be hard to do frame analysis for each frame, because for example, we have 30 frame per second video that will be like a 30 frame per second. It will be a lot of frame to process, and it will be taking a lot of time to just process a simple video. So we decide to take just a couple of frames per that range, and the range is dynamic, so we can change it later on if we would like to, based on the video duration or other metric that we can later on discuss. The second or the third process will be scene creation. So we are combining the transcription data that we got with the frame analysis data that we got and create a scene data that will be have all the information about the faces, the object, transcription. We have also include the metadata, for example, the location where the video has been shot, also the camera name. So later on, we can have some great information about the video scene. The fourth part, it will be embedding. So we convert that scene into a text document that will be having all the description of the scene. For example, everything that we get from the scene, as I mentioned before, and we save it in a vector database that will be responsible for only text embedding, and we are using ChromaDB. And also we have one more thing, which is visual embedding. So after getting the text embedding, we can just do some basic search, but we don't know what the frame is looking like. And also same for audio, because we can get some great detail from the visual and from the audio from the video frame. So for each video scene, we take a couple of frames using FFmpeg and get the image embedding and save it over a separate DB collection for visual embedding specifically. We are doing the same for audio. We're taking the audio using FFmpeg and getting the embedding using a local model to be able to save it on a vector database. So currently we have 3 steps. We have transcription, frame analysis, and scene creation. After that, we are doing the embedding. We will end up with 3 vector database collection, one for text embedding, one for visual embedding, and the third one will be for audio. So later on, when we are searching, we can search across all of them. So for example, we can just have a query that will be a text, and after that, this query, we can get a text embedding for that query and do semantic search over the vector database for text. We can get the query and convert it to our image embedding and do it for the visual. And we can do the same for audio. So we can combine all the results for the same query and try different collection. So it will have higher chance of getting accurate result instead of relying just on text, because text is not enough to describe a scene. So we are including other stuff to enhance the embedding. So for the services that we have the web application. Is just a basic web app that will be just serving the UI. So the people can add the folder to start the scanning. And the second thing, it will be the background drop. So we are using Node.js with the Express.js with bulk MQ to manage the queue. And this will be sitting between like the web application and the Python script. So it will get in the request from the web application to be able to scan the video. It will be scanning the video and get all the video. And after that, it will be sending that request to the ML service, which is a Python script managing the heavy part, which will be transcription and frame analysis. And we are connecting from the Python script to the background job that is Express.js using WebSocket. So we can communicate, and also we can external make the service hosted on different, not only on Docker. So currently we have 3 Docker container, one for web, background, and ML for the Python script. So the technology stack I mentioned for the backend, I already mentioned that. For the ML model, we are using deep face for face recognition with the VGG face model. We are using YOLO with ultra LaTeX for object detection. We are using easy OCR for the text that will be appearing on the screen. We are using OpenAI Whisper model for the transcription. We are using Olama for the natural language processing, so we can get the user query and convert it to a search query that we can use to be able to get the stuff that we need from the vector database. For embedding, I'm using ChromaDB as a local vector database. I am using Clip for image embedding, Clap for audio embedding, and all up MPNet based V2 for text embedding. Everything is running locally, and it can even run offline. So everything can be running offline if you already have the model cached. So enough talking about the stack, and I would love to share Ilias Mind and what it's capable of. So this is the web application. So currently we have a couple of video indexing, and I will go to one of the video and I will play it. And as you can see right now, this is all the object that has been detected, and also the text, the faces. We have a face training data set. So when we are like doing face recognition, the user can label the faces. For example, I am doing the first time I'm processing a video, I will get a lot of unknown faces and I can label them. So the system will know that this one is me and this one is like my friend, for example. And also we are doing unknown face clustering. For example, if an unknown face is presented in frame number 1 and frame number 100, for example, it will know that this one is the same person, and it will like save them. So the people or the person that is using this service can easily label the faces without having a lot of different faces to label for the same person. So currently this is for the video itself. I will show you one right now with the dashboard. So this one doesn't have anything. I will go to the search. So I can, for example, I can just type search. I can go for pizza and it will give me all the exact scene where the object pizza is founded. For example, I can search, for example, let's do bicycle. So it finds all the objects where a bicycle is found. Let's do faces, for example, myself. So this will be taking all the faces that we mentioned. I can go to image search. So I can go, for example, here. And I can just take a screenshot of my bike and go here to the image and drag it here right now. And it will give me all the exact scene where my bike is founded. So where is in the green dot is where the scene is matching the request that I am getting. So this is for text search and image search. Let's go to chat. So currently in the chat, we are using, you have the option to use Olama or Gemini or a local model if you would like to. So currently I can just go and
what's up?
The chat to be able to give me all
Gotcha.
like a moment with Ilias. So the first thing it will understand, the request and give me what I am looking for. And after that, you will be searching the vector database to give me exactly the scene that I am requesting from the user input. So why it's because it might be taking some time, it's going to be searching for relevant scene. That's good. So it will be give me all the scenes. So I can just select the scene that I'm looking for. I can have two options. I can combine them to one video that will be stitched, or I can export them as a zip file. So later on, I can go to my favorite video editor and start editing. So let's go and export them. So it will be exporting. This might take some time. I will go to the next feature, which is collection, while waiting for this one to be done. So for collection, when we are doing the video, and this one, it will be running in the background. So we have some collection pre-definition, and we have some embedding for each definition. So currently we have type of subject. So for example, it will combine all the video scene where we have type of conversational talk. So we have this one. It will be just a conversational talk. as you can see right now. We have, for example, emotional tone. It will be like, let's say this one, competitive. And we have other one that will be, this one is will be just based on the metadata for geographical location and the person as well. So it will be just combining the faces with the same, it will be combining just the video with the same faces. And we have B-roll. So instead of like using like a stock footage, you might find some B-roll to use in your video from your video library instead of getting them from like a stock footage website. We have projects. So currently in projects, I can go to one of the projects. So here, it's currently refreshing. So in the project, I can just click on this one. So in the project, I can select a couple of video and I can have instruction for the AI model. So I can just say that this is my podcast and this is season number 2. I can select the video that I'm looking for. So when I am prompting or chatting with the AI, I can just limit the search query to the project that I'm looking for. So the AI can know the video to search for, so it will just limit them. And also we have instruction about what this video is about. So this one of the feature. And we have face training. So this will be, for example, when I am like a fresh, it will doesn't have any faces, so I can just label the unknown faces. I can go to the faces. So this will be the one that will be using by deep face and the VG face model to be able to find the similar faces. So, and also I can just click here to be able to search with the faces. So this one for the faces. Let's go back to the prompt. I think it's still running. Yeah, this one it's already done. So I can just export the zip file, can double click. And here I have all the scene that is getting. So I can just drag and drop them to be able to like filter edit the video itself. So this will be just give me a starting point of the video scene that I'm looking for. And later on, I can just go and edit them on like a DaVinci Resolve or Adobe Premiere Pro. So here we have the settings, so we can just add a folder and the process will be starting as soon as we have. So currently the project is open source. So you can just go to GitHub and slash Ilias Haddad slash edit mine, and you can like I try to yourself. The project is still in alpha. There is like I still in very early stage. It's just currently a proof of concept. I'm still working to be able to make sure that it's bug free and making some contribution to improve the system and the reliability. But currently the system, as you can tell, everything is running locally 100%. If you want to use Gemini, we'll not be sharing the video data. We're just converting the query to a JSON so we can use them for the vector database to search by face, by semantic query, and everything else. So I think that's it for my presentation.
Nice.
And thank you so much.
All right. Thanks a lot. Appreciate the detailed walkthrough and demo of the application. All right. I think there's a couple of questions already on the chat from Ian and Nayib. So, I mean, do you guys also want to just ask this question live? Maybe Ian, you want to get started?
Sure.
Yeah,
Can you guys hear me?
Yes, we can hear you loud and clear.
So that was amazing. That was a very cool project. Congratulations, dude.
Thank you so much.
First of all, I love it. How is it live? And I've seen 1,000 commits. You've been working on this for long?
It's almost like 3 months or 3.5 months, I think.
Damn. Okay. That's pretty cool. And I love how you posted on Reddit and so many people found out. I started to find out and I'll try it. I was just looking at the environment variables. Anyway, the most interesting part for me was the tagging. I saw on a comment you did tag a name, so you can go through the videos and tag a name and search with the name of another person. Can you explain this again? one more time?
Yes. So currently, when I am like doing, you are thinking you are talking about the search by face, I think.
Yes, yes.
So currently, when I am like doing the indexing, I am getting the faces recognized by the deep face model, and after that, I'm converting to them to a scene, and after that, I'm saving that like a scene with the metadata, and the metadata will include the faces. So when I am doing the search by face name, I can just go directly to the vector database and just filter by face. We have like the metadata. So currently the vector, like the document in the vector, we have the document itself, and we will have some metadata. The metadata will include the faces that has been recognized in that very specific scene, and also the object that has been detected. For example, when I search for pizza, it's already know that there is a pizza in like a scene number 3 that is like a starting from like a 2 to like a 5 second, for example. So this is
And
how it's working. So we are indexing the like how we are doing the embedding, we are also including the metadata as well. That will
you
include
said
the faces.
you converted to a scene or to a scene?
To a scene, like a video scene, because currently
To a scene, to a scene.
yeah,
Okay,
a
I
scene,
see.
yeah, because we are
Okay.
taking the video like the full video and taking it onto smaller parts as the system we call scene. So it will be just
I get it.
like a small
So the starting time and end time, start time, end time.
yes,
So like
exactly.
2 times. Okay, now
Yeah,
that makes
exactly.
sense.
Yeah.
That's very smart. Cool. All right. Again, I just started your project. That was amazing. Thank you for your presentation.
Thank you so much.
All right. Liam, you have your hands in a bit. You want to
Yeah,
ask?
cool. Yeah, super cool project. I was most curious like how the project currently handles like kind of temporal actions. So things like someone falling down. Is it good at that type of stuff? Like stuff that has a temporal dependency and maybe even like really long windowed stuff? Or if you're looking at handling that in the future.
So currently, like for example, the system, when we are doing the analysis for the frame, we are getting the object and the stuff, and we have another plugin that will be describing the scene. So it will be just a model that will describe the scene. So for example, I'd say I am like riding my bike. So it will describe a man riding his bike. So this is like will be a description of the frame. It will not like handle the windows as you mentioned, like for example, if someone is falling down, but maybe in the future it could be handled, but as of right now it's not like implemented. So currently this is just a proof of concept. There's still a lot of improvement to be done. This is like one of the earliest version of the projects.
Cool. Well, really nice job. Very cool. Thanks for sharing.
Thank you so much. Thank you.
Great. Nayib, do you want to unmute and ask a question live?
Yeah, sure. Thanks. Thanks for the talk, Ilias.
Thank you.
It's very helpful to understand how that works. I guess we've me and my team have kind of worked on something similar for finding so kind of matching across videos. So if we already have a video, I want to find a similar, like let's say I have like a 5-second part of that video. I want to find that a similar 5-second part in all the other videos in our database, right? And the challenge we've had is looking at, like all the embeddings together. So text, visual, and audio. Technically, we don't have audio. We just transcribe the text, the audio. But yeah, I'm curious how you were able to like search across the three, or are you just searching each individually, or how does that work?
Yeah, for the search, like you can search by only text. So you can just search for the text collection or the visual collection or the audio. But currently, like for when you are searching by text, I'm getting the query. For example, I'm searching for, let's say, someone is smiling. So I'm like first going to the text collection. I'm searching for like an emotion, for example, happy, and also I'm doing like a semantic query. So I'm getting that query and convert it to a text embedding and do semantic query with the Chroma DB. Will be for text collection. I'm doing the same for the visual collection because in the video I'm taking a 5 frame per video scene that will be short, like it will be like a 2 or 2.5 second in terms of duration. And after that, I will be passing that to the visual collection to be able to get, for example, the face that will be smiling, for example. It will be the same for audio. We are using FMPEG and extract the audio for that specific part and getting the embedding using I couldn't remember exactly the name of the model, but a local model to be able to get audio embedding. For example, the audio embedding can detect, for example, if someone is laughing. So it will be considered as a smiling, for example. So it's if a laugh is is there in the audio, it will be considered as smiley. And we are like combining all the results and getting all the best, like we are scoring them. It will be like a basic scoring, nothing is like a too fancy there, but just combining the scene and getting all the unique scene from that and displaying that in the result.
Okay, got it. So it's basically doing it separately for all three and then
Yes.
combining it
Yeah,
and
exactly.
giving
Yeah,
some
just
basic
combining at the
scoring.
end. Yeah.
Okay, awesome.
Thank you.
Yeah, makes sense. Appreciate it.
Thank you.
All right. Any other question for Ilias? We still got like, a couple minutes left.
I just would like to mention that the project is still in alpha version, so you might expecting some bugs. So just feel free to open an issue, and I would love to like fix them.
Yeah, so like if there's no other question, then I guess we can close down the webinar a little bit early. Yeah, thanks Ilias for walking over the demo again. I think it's
Thank
a
you.
really nice replication, in a local manner, right? All the key capabilities from 12 Labs, but like I think the power here is that you leverage open source project, local models, or Llama, right? Llama CCP, ChromaDB, like all these tools that like an easy, like a developer, right, can pip install and like quickly use it for their own workflow. So it's very powerful for applied setting, right? Which is very nice. So yeah, I
Thank you so
appreciate
much.
like kind of your walkthrough of this project, and excited just to see more adoption of it. As you already released a more stable, right, version of the project.
Yes, yeah. Thank you so
Yeah.
much for giving us this opportunity to present this project, and it's been a pleasure to like present this project. It's a really great feeling to present this project.
For sure. And just a note on like the use cases, I think like on-prem deployment, right? On low latency scenario, right? Like on mobile or like on edge device, I think could certainly require like local inference. So I think like
Yes.
this kind of like what you present here like can have pretty good like applicability in those settings.
Yeah, exactly. Yeah. So currently the next big feature that I'm hoping to get out is like an integration with a video editor. So you can just when you are like opening your video editor, you can just exactly search for the scene that you are looking for. And you can just drag and drop to the editor and start the editing. So you don't need to think twice about where and you don't need to think about finding the exact scene. So it will be just there sitting ready for you to get. But the bottleneck it will be because it's local. It will be like requiring some. It will be slow compared to other provider.
Yeah, for sure. All right, thanks everyone. Appreciate your time today. Thanks both Haro and Ilias for spending your time and preparing the slide and educate the community on your research and your projects. And the recording of this session should be available on YouTube maybe like in a few days or so, and I'll be sure to share that with the speakers and to stay up to date with like what's going on with the webinar. I would recommend everyone to join our Discord server. So yeah, so you can like know who's going to present next week, etc. And yeah, if you enjoy this type of content, good luck to have you join us again for future Multimodal Weekly. Yeah, that's all I had. And thanks everyone. Enjoy the rest of your Friday. Cheers.